good afternoon. This is the A-level video for differentiation leading to tangents and differentiation leading to normals. Anyone who's currently doing year 12, this may well be where you got up to in your studies or what you were working towards. Anyone who's not in year 11, maybe this is something that you'll be moving on to. If you don't know about differentiation, then there'll be some things in here that don't necessarily make full sense, but just make sure that once you've followed through this video and accept that this leads to this, and I'll explain that it's using differentiation, you can then go and watch a video on differentiation. I did one earlier in the week that would explain to you where that comes from, and that should help. So apparently I've got 4 or 5 people with me. I'm sure some more people will watch it later. So let's get this going. Please feel free to ask any questions in the comments, or if you've got anything in the live stream or in the comments below the video if you're watching this at a later date. I will always try and respond to any comments that people pass on, any questions, anything that didn't make sense. I'm still learning this. I've been doing it for a week. Lots of people have been live streaming for months and months and months. I'm an old man as well, so those people, these youngsters who are doing sort of their videos for Fortnite and Roblox and things, and there's me just trying to teach a bit of maths. So please be forgiving. Let me know any feedback you have for me. It's all gratefully received. So let's move into where I'm going to be able to help you, and that is here. We are going to be looking at the gradients and the differentiation for tangents and normals. And in order to do that, I think a good place to start is to draw y equals x squared. And we're going to hope that it's going to do it first time. It is. So here is that graph. So what we're talking about today is gradient, the lines that represent tangents and normals at the different points. What that means is, let's say I choose a point here. The tangent at that point is a straight line that touches but doesn't go inside. So I will need to move that over so it's touching, something like that. That is going to be the line that we want to know the gradient of if we're going to do the tangent of the equation. And let's say we gave ourselves the value x equals, and I believe it's 4 there. We'd quite like to know the equation of this line. And that's the first thing we're going to make sure we go through. In this line, we know that the gradient dy dx is equal to 2x. And we also know that we're looking at this when x is 4. So at x equals 4, dy dx is equal to 8. Because this gradient is different depending on which part of this curve we use. In fact, if we use it on this side, it's going to be a negative line. So we need to make sure we plug in x to see what this value is to get our gradient for that specific space. Then we know that y minus y1 over x minus x1 equals m. Now this is fancy talk for y, which we're going to keep, is equal to, at this point here, which we know has 4 as the x value, we're going to call that x1, and we need a y1 value. But we know if x is 4, that y1 must equal 4 squared, which is 16. So at 416, which is what this point must be, we have this equation is the universal equation for the gradient. So we can say that for the equation, for the straight line, sorry, we can say that using the information we've got, y minus 16 over x minus 4 is equal to 8. Because we got that, this is m. m is the dy dx, the differentiated value of the equation when you plug a number in to the equation itself. So we've got that y minus y1 over x minus. Now we just do a bit of rearranging. We're going to multiply all of this to the other side. So y minus 16 equals 8 lots of x minus 4. Y minus 16 equals 8x minus 32. So I think if I add this 16 on, y equals 8x minus 16. And that means this red line will go through at minus 16, and it has a gradient. Every one it goes up, it's going to go up 16. And we can just about see that there. It goes along 1 and up 16. So we've got y equals 8x minus 16, not up 16, so it goes up 2, 16. It goes up 8 for every one it goes along. I do apologise. I don't like leaving things that aren't correct. This is the using differentiation to find the gradient of a tangent. We're using the differentiation to find the gradient here of a tangent. Let's go through just a few of the steps. Step 1 was we were given the question and we were given information within the question. We were given that bit and we were given that bit. Step 1 was to find the point, the y value at that point and create this new thing. So step 1, we found when x1 was 4, y1 was 16 by putting 4 into the equation itself. Step 2 was to find the gradient of the equation by differentiation. Step 3 is to plug in the new x value at that point into the gradient. That will then give us a value for the gradient, which in this case is going to be dy dx is equal to 8. So we've now got x equals 4 goes into there. Part 4 was to use the universal formula for any straight line equation. Some of you might use y equals mx plus c. That will still work. I prefer this one, but either of them are valid and valuable. Okay. The next one says step 5 is rearrange our equation until we've got y equals. Another way of leaving that, which is perfectly valid, is y minus 8x plus 16 is 0. Sometimes the question will ask you to leave your answer in the format y, x, and a number and 0, or x, y, a number and 0. So you can rearrange your equation to fit to match. Hopefully that's making sense so far. I'm sure if anyone is here watching and isn't completely bored out of their mind so far, then they'll put some comments in, and I'll try and keep it light and make sure that we're following on what's going on. The next one I'd like to do, we scroll down and we've got this example. So we've got a harder question, but we want to be able to follow it through. First of all, it might be useful for us to see what the equation looks like. So I'm just going to quickly remove myself to give us a little bit more space. And hopefully we'll now have space for me to write y equals x cubed minus x squared plus 2x. And we've got here, it doesn't quite like that last x. It hates it when I do curly x's. Really annoys me. So we'll do this and turn that into maths. And we're going to draw the graph. And we're going to insert it onto the page. There it is. And I think I want to zoom in a little bit to make it more beautiful, because we only want the point 2. So let's just make it so the point 2 is visible. That's what it looks like there. So it's asking us just here at the point 2 if I draw a line there for the tangent, what is the equation of that line? So let's go through our steps without looking back at our previous work. Let's see what we can remember. Well, the first step, we know that x is 2. So let's find the value of y. We're going to put 2 cubed minus 2 squared plus 2 2's. I believe that's 8 minus 4 plus 4. They're going to cancel, so the answer is 8. And you could see that from the graph because I've drawn the graph for you. But obviously if we're doing this ourselves separately, we don't have the graphing software to work for us. What this tells us is our coordinate that we're working on is the point where this tangent is taking place. So we've got an x1 and a y1. We can then use that to differentiate. So I'm going to take my differential, dy dx equals 3x squared, drop the power, times by the power, so minus 2x, and it just drops the power, plus 2. But we know that x is 2. So let's rewrite that as equals 3 lots of 2 squared minus 2 lots of 2 plus 2. 2 squared is 4, 3 lots of that is 12, minus 4 is 8, plus 2 is 10. So we know dy dx is equal to 10. We can now use that to state what the equation will be, because we've got y minus y1 over x minus x1 equals m. So y minus 8 over x minus 2 is equal to 10. Again, multiply things out, is 10x minus 2. Y minus 8 equals 10x minus 20. So y equals 10x. Don't forget that when you add 8 to minus 20, you get minus 12. And we've got an equation, and again, it depends on the formula. This would be the equation to the tangent. You will manage to make it halfway through the video. Congratulations, give yourself a pat on the back. Don't give yourself a pat on the back. Okay, we are now going to look at, once we've done this, we're now going to look at what happens when we're doing a normal. Let me just move this question down. We've got more practice on the normal, so we're going to use this example as our equation for the normal. Now, the normal, what is going on with the normal is when I do my equation, y equals 3x squared, x squared, it's not going to like it, is it? So let's just fix that. 3x squared minus x. You can see I've got myself so programmed into doing x's properly. And we're going to draw that graph. And it wants to know at minus 1. So normally, when we were fighting, not pun intended, it's a shame because that would have been hilarious. People have been going on the record going, that was such a clever pun and I didn't even mean it. That's frustrating. What it's saying to the normal is, if I go perpendicular to that line through the point we're talking about, what's the equation of that line? So if we're talking about the point, that line there, if that's where it's minus 1, and it's not, it needs to be further over, minus 1 at there. Because we're focused fully on x being minus 1, which is there, it's that point there. What's this equation? This is the normal. So what is the equation of that? Unfortunately, there is a year 12 formula, AS level formula that comes into it, which states that m1, where m is the gradient, times m2 is the gradient of the normal. So we've got the gradient of the tangent times the gradient of the normal, make minus 1. So we're going to have to find the gradient of the tangent just like we were before, but we're going to have to do some jiggery pokery first. So we follow the steps exactly as before. First of all, we've got the value x equals minus 1 here. It would be quite nice if we had a y value. So let's pop it in. Minus 1 squared, 3 lots of that, minus minus 1. I make that 1, 3, 4. So we've got our x1, y1. We then are going to do our dy dx. And we get 6x. And that is minus 1. Popping that minus 1 in, we get minus 6 minus 1 equals minus 7. So we know that the gradient is minus 7, but that's the gradient of the tangent. We want the gradient of the normal. And the gradient of the normal multiplies by the gradient of the tangent to make minus 1. So the number we're going to need is 1/7. Because whatever we need is 7, it's going to be the negative reciprocal. It's whatever multiplies with 7 to make 1, but it's the negative version, therefore it's going to be minus 1/7. What we can then do is we can do everything as per. We've still got the same point that we had before. This is a point, this is the red point here. Probably should have done it in green so we can see. This green point here, which it was green the whole time, I don't know what you're talking about. That's the green point there. That's still the same point. The normal goes through the same point as the perpendicular. Because it's perpendicular. It goes through the same point as the tangent. Therefore, we can use the same process of y minus y1, x minus x1, but we want not the gradient of the tangent, but the gradient of the normal is 1/7. So we've got y minus 4 over x minus minus 1 is plus 1 equals 1/7 times both sides. I'm going to times that to that side and that to that side. We've got 7 lots of y minus 4 is equal to x plus 1. So 7y minus 28 equals x plus 1. We've got 7y equals x plus 29. And if you want to tidy it up, you can either rearrange and put them all on the left hand side, or you can even write y equals x over 7 plus 29 over 7. But I prefer to have it this formula. I think is your finished equation. I'd be happy with that as my equation of my normal. What I've then done, there is a worksheet linked in the description which you can go to, and I think it's got some good explanations and it's got an exercise you can complete when this video is finished. What I've also done is I've put at the bottom here, and if we just get rid of this, it's a nice grid that if I centralise that so that you can all see it, you could pause the video now and work through each step of those things. So you could have a look. It's got the step-by-step approach to finding the normal of each equation. The value of m, the value of dy dx, putting them in. Let's do the first one, and you'll see hopefully it's exactly as I've been going through all of the session. So for this one, 5, so it's 15x to the 4 plus 4x, and x equals 1. So the value of dy dx is going to be 15 times 1 plus 4 times 1 is 19. Where the next stage is the value of m. Well, if that's the value of dy dx, the value of m is this is the normal now, so it must be minus 1 divided by that is minus 1/19. The negative reciprocal of 19. The next stage is we're going to look at what are x1 and y1. Well, this was our first stage, but it doesn't matter which order we do things here. If I put 1 in, we have y equals 3x to the power 5 plus 2x squared. When I put 1 in, I get have a horrible feeling my Mac has just gone into the saving mode. I do not know if it's switched off the live stream, which would be very frustrated. I will assume it hasn't, and we will see what happens if I bring it up. If this is not, if you can't hear this, then you're not hearing it. If you are, I do apologise. But we have a horrible feeling that it might have disappeared. Right, let's assume it hasn't. We've got, when we put x into here, x is 1, we've got 3 plus 2 equals 5. We then have y. It looks like it's still been going, so I do apologise for the silly pauses. We have y minus y1 over x minus x1. Is y minus, and we got the value of we had was 1, 5, y minus 5, x minus 1 equals minus 1 over 19. So we've also got that is equal to y minus 5 with a 19 equals minus 1 x minus 1, 19y minus 85 equals minus x plus 1, 19y equals minus x plus 86. And that's the rearranged version. I have no idea if you've seen all of that. So, that would be the end of the video. You can conclude there. I do apologise for the things at the end. If you have seen it, then brilliant. If not, then I do apologise. Thank you for bearing with my technical problems. I will be back shortly, and thank you very much.